Hello! Welcome to the Appalachian Center for the Arts presents Dr. Flackenquack's Super Silly Science Squad. I am Dr. Flackenquack. Come join me. So, welcome to our laboratory. I, of course, again, Dr. Flackenquack. So this is Dr. Flackenquack's lovely laboratory here at the App, the fine people here at the Appalachian Center for the Arts. Now, you may ask, why would we be doing science at an arts facility? Well, let me tell you. The arts are everywhere, and the sciences are everywhere in the arts. Every light you see, that's electrical engineering. Every sound you hear from the stage, that is acoustic engineering. Anytime you see someone step on a stage and it doesn't fall apart, that is structural engineering and the laws of physics in play. Arts are science and science are arts. It's all a jumble and it's a wonderful thing. So first, I would like to introduce you to my assistant, Dr. Flackenquack Jr. No relation. Can you imagine the coincidence? So today's experiment is going to be the amazing erupting volcano. And we're going to be able to do this with some ingredients that have been posted on the website, and you probably have most of them at home. Come along. The first thing we need are supplies. Supplies! See, that's a little experimental humor. Of course, my wife says all of my humor is experimental. Anyway, what you need is an empty bottle. We chose a big bottle because we're making a big volcanic eruption. Then you need some white vinegar, baking soda, water, dish soap, food coloring. We've chosen red and yellow. And then 2 empty cups. We also would like to have a plastic fork for mixing. And always good to have paper towels on hand in case you make a mess. So, the first thing we'll do is mix the ingredients that we're gonna use. First things first, the vinegar. All right, now why do we choose vinegar? Vinegar is an acid, a very weak one, and it goes lovely in chicken soup, by the way. But vinegar is an acid, and I'll explain what that means. Water is the neutral fluid. That means that it's not too acid, it's not too base, it's just right, kind of like Goldilocks. Now, acids sit on one side of the measurement. Bases sit on the other. And they all want to move towards neutral, which is water. Thank you. So, we're going to start with 1 cup of white vinegar. Now, the 1 cup is because we're using a large vessel. If you're not using a vessel that large, you can have a third of a cup, a half of a cup. Judge it by that, because you want basically equal parts of vinegar, the acid, and nearly equal parts of baking soda slurry, which is the base. Now, a slurry just means you mix the ingredients together. Thank you, Dr. Flackenquack Jr. You're most helpful, and your visual aids are impeccable. Now, before you mix the baking soda into the slurry, if you're going to use the same measuring spoon or device as we are, dry it out and clean out. Otherwise, you'll have an eruption in a cup. And while that sounds like a delightful dessert, it is not what you want in the sciences. So, we're going to do 2/3 of a cup of baking soda. Make sure you have enough room here so the baking soda dust doesn't come up all the way up. Thank you, Dr. Flackenquack. Anyway, then you will mix about 1/3 of a cup, my goodness, of water in there. Now we're going to do this to make a slurry. If you would mix that, please. It's going to be almost like a paste. That's it. Like a thin paste. You need some help there? You're good. Thank you. Really get all of it up there, yeah. You'll see it's a little bubbly, but that's okay. There we go, get all of it up there. It's gonna look yucky. Just what we want. If our camera person would get closer, you'll see that it's sort of a thick, thin paste. A little liquidy, which is good, because we've got to get this paste into the bottle. In fact, I'm going to thin it out slightly, and that's a good thing. There, that's more like it. So, the first thing we do is pour our slurry into our empty bottle. Ooh, the excitement begins to build. Make sure you get all of that good baking soda from the bottom, as that's going to be the fuel for our experiment and what we're going to call our chemical reaction. See, she reacted. It's wonderful. You have a very lovely mustache for a little girl. And I love that you've cultivated your eyebrows. It's a wise move. Then, we're gonna add a little bit of dish soap liquid. Now, why? It's really just to make the reaction formula a little thicker. It'll look more like lava and less like, you've opened a can of Ale 8 after shaking it up. For those of you not in the Kentucky area, Ale 8 is a delightful beverage with lots of bubbles. Then, to make sure that we get it to look like lava, we're gonna put drops of food coloring. This time we chose red. Squeeze a little. 1, 2, 3, that's perfect. Thank you. You are so precise and clean. And then even though this looks like orange, it's yellow food coloring. Again, wonderful. Put 2 in there, please. 1 and 2. Ooh, didn't want to go in. Anyway, our other one is the white vinegar. Do not put these 2 together yet. Do not, otherwise you will have an eruption right in your face, and that is not what you want. I know it would be very funny. Good. The final thing that you really want to do, and you join me over here, is as always, after working with anything, use hand sanitizer and wash your hands very thoroughly. And something that they don't always tell you, after you rub it and really get it all over, don't forget your thumbs, okay? And the back of your hand, don't touch your eyes. Because if you touch your eyes, this'll happen. So, welcome to the outside of the Appalachian Center for the Arts. We are doing the rest of this experiment out here because we have no idea how much lava will go everywhere. It's not really lava, it's not lava at all. But still, it could be a big, wonderful mess, and we'd rather have it here outside than in my lab. Therefore, mothers and fathers, grandpas and grandmas, aunts and uncles, and all you science lovers out there, we suggest that you do the actual experiment outside so as not to stain any fabrics in the home. So, we have our slurry mixture, which we're gonna stir up nice and stirred, mixed with, again, it has food coloring, red and yellow, and then also it has a little bit of liquid dish soap. We're gonna place that on the ground. Now, if you would like your actual volcano to look like a volcano, you can take masking tape and wrap newspaper around it so it looks like a mountain, and then paint it with all the craft stuff that I know all of you kids have at home. You crazy crafting kids. They're just crazy crafters out there. There we go. Good. In this class is, as you can see, white vinegar. Now here's the thing with this. What's about to happen is called a chemical reaction. The acid, which is the vinegar, and the base, which is the slurry in here, when they mix together, two atoms of oxygen grab a hold of an atom of carbon, and they get married. They hold on to each other, and they form something called carbon dioxide. Now, carbon dioxide is the fizzy stuff inside of every wonderful soda that you have. And they're bubbles, right? And they're pressed into the fluid in the soda, which is why they stay there. And as soon as you open it, what sound does it make? And that sound are the bubbles gently bursting the surface of the liquid and releasing into the air, which is what they like to do. Now, what happens if I take a bottle of soda and I shake it, what happens to the bubbles? What do? They get super excited and they burst forth. So, the chemical reaction of adding the acid to the base causes a lot of carbon dioxide to be made, and it bursts forth, all of the bubbles forming and bursting all at once, and they all boom, come out of the bottle. So stand back, Dr. Flackenquack Jr. Here's hoping this works the way I want. Oh my goodness. Oh my goodness, I'm so glad we did this outside. Oh, you see it just oozing out. Could you imagine that on your mother's sofa? I know she can't and doesn't want to. So from 1 cup of acid and 1 cup, less than 1 cup, of base, this entire bottle filled with foam. And you can see the big giant bubbles there, and if I squeeze it, you'll see them even more. Every one of those bubbles is filled with carbon dioxide, and they want to get out into the air. And you see, it filled this entire 2-liter bottle. Now, had we done it in a smaller bottle, it would have exploded out of there with great force. Had we done it in too small of a bottle, and had the opening been too small, those bubbles would have burst inside of it and possibly burst the side of it. So you have to be very careful. So that was our experiment for today. Thank you so much for joining Dr. Flackenquack and Dr. Flackenquack Jr. at Dr. Flackenquack's Super Silly Science Squad here at the Appalachian Center for the Arts.